Alright, let's determine the equation of the tangent to the graph of each curve at the point that corresponds to each value of x. In this case, we have y is equal to 6x minus 3 times x squared plus 2 at x is equal to 1. Okay, so if we want to find the equation of the tangent is y is equal to mx plus b, right? And we need to solve for the slope and the y-intercept of the tangent. Well, the slope of the tangent is basically the derivative of our function dy over dx, and we want to figure out the slope of the tangent at x is equal to 1. Okay. The equivalent point of x is equal to 1. Before we actually start, we figure out the slope of the tangent at x is equal to 1. Let's figure out what this actual point is. So I'm going to do f of 1. I'm going to pretend y is f of x. It's really the same thing. F of 1 here is basically 6 times 1 minus 3 and negative 1 squared plus 2. And this is going to give us 3 times negative 1 plus 2, which is 3. Okay, so f of 1 is equal to 3, so the point is 1 and 3. So I just kind of figured out what this point is, right? We're finding the slope of the tangent at the point 1 and 3. Okay, so let's find the slope of the tangent. So let's first find the derivative. So I'm going to be using product rule, so I'm going to find the derivative of 6x minus 3 times negative x squared plus 2 plus the derivative of negative x squared plus 2 times 6x minus 3. In this case, you get 6 times negative x squared plus 2 plus the derivative of, well, in this case, there's going to be a negative 2x times 6x minus 3. So then you get negative 6x squared plus 12 minus 12x squared plus 6x. And then you can see that you get negative 6x squared minus 12x squared, so that's negative 18x squared, plus 6x plus 12. Okay, so this is your derivative function. Okay, and then what you want to do is you want to find this at the point of x is equal to 1. So we get negative 18, I plug in 1 into your x values of your derivative function, and you basically get negative 18 plus 6 plus 12, which is 0. Okay, so the slope is 0. If the slope is 0, then we know that y is equal to 0 for mx plus b, so y is equal to b, right? And all you have to do is really just substitute a point, right? So if you substitute a point for y, b is, if you substitute 1 and 3, so b is equal to 3, so therefore the point is y is equal to 3. Okay, so this indicates that's a horizontal line. So whenever the slope is 0, this will indicate it's a horizontal line, right? And pretend this is 3, right? And this is where the line would extend. Okay, and you would usually see horizontal if the slope is 0, right? This usually occurs at extrema. So extrema include maximum or minimum points. Like for instance, if a parabola, if this point here is the vertex and it's concave up, then basically we would have a slope of 0 at the vertex, like that, right? So m is equal to 0. Here's another parabola where it's concave down, and maybe this point here is the vertex, and we would also have another tangent that is 0 at that vertex. So it's a great point. It's a great way to kind of look at maximums and minimums. This is going to be really key when we look at optimization.